but I want to discuss it today. All right, so Pythagorean Theorem, we talked about it yesterday. It was a right triangle, okay, and a right triangle here. You sum the squares. Now, what does the word sum mean? Add. So we're going to be adding the square of the legs. Now, on this picture, which ones are the legs?
Touching the right angles.
Exactly. The legs are the ones that touch the right angles. It's these two. Okay, so these are the legs. So whatever these are, you're going to square them. So that means put a power of 2, as you can see here, and then you add them together, and that should be equal to the hypotenuse, which is the largest side. It's the hypotenuse squared. So those two walls are related to the other one. Now we talked about yesterday like the common sense idea that in a triangle, because I always get the question is like, why can't you just drop the squares? You can't do that. It's common sense when you look at the picture. Somebody help me. All right. Anyways, that was weird. All right. Anyways, A and B, you would actually add those together, and then a lot of people always wonder why can't you just set it equal to C? Well, the thing is, it's a shortcut, right? If you're standing here, this is the thing we talked about yesterday. If you're standing right there and you're going to walk a straight path, or let's say this is your house over here, that distance should not be the same as somebody walking around the corner. Okay, the shortcut home should not be equal to the person walking around the block. That's why this doesn't work. It's like common sense. Okay, so that's how it works in a triangle. But for the Pythagorean theorem, somehow when you square them, it makes it work. All right. Now, what I want to talk about today is if I were to throw numbers in here, can we actually use that to solve this problem? So here's what I want to talk about. Let's say that I gave you A was 3. B was 4, and I want to know that little guy. I want to know that little piece. I want to know what the letter C is. We can use this theorem, the Pythagorean theorem, to actually help us find that. That's what we use the Pythagorean theorem for. Now, the best part about the Pythagorean theorem is it doesn't matter which wall is missing. It doesn't always have to be the hypotenuse. That's the one that I had missing in this case. But it can be any of the other walls. You just need to know where to plug them in. So when you look at the formula, and again, this is the formula here, these have to be the legs. So I don't care if one of the legs is missing. You got to plug those variables or numbers on this side. The hypotenuse is over here. Okay, we're good? Okay, so my numbers are 3 and 4, and then I want to find x. So when we do this, so my legs are 3 and 4, we're going to square them and add them together, because those are my legs, and then that'll equal the hypotenuse squared. That's what we talked about, right? So, what's 3 squared?
9.
9, okay. 4 squared?
16.
16. And that should be equal to x squared. We add those together to make 25. And how do you solve an equation where there's a power? Move it over, and what do we do with it? Yeah, a root, right? So when you move this over to the other side, so when you take that power of 2 off, you do the square root to the other side, and it turns out to be a nice, pretty number. It turns out to be 5. The square root of 25 is 5. It's 5 times 5, right? Now, if it wasn't a pretty number, you could type it in the calculator, get the decimal of it. We could break it down, as we've been talking about all last week. We talked about how to break down radicals, how to simplify them in simplest radical form. But that's the idea. Okay? Alright, here's what I'd like you to do. If you haven't already, I'd like you to write those down. And then what I want to do is I want to try to make up some problems today where we try out a few on the board where we're going to plug in numbers in random spots and see if you guys can figure them out. Okay? Alright, so everyone have this written down. If you're still writing, I'm going to leave it on the board just for a few seconds. We'll try one more where we'll put an X in a different spot. And then we're going to try out to make out a couple on the room. Okay? And I want to walk around and check. If you need a calculator, I would definitely recommend you take it out right now, or go to the back of the room and go grab one. You don't need one. Numbers we're about to make up are not going to work out nice and pretty like this one did. I'm not going to fix it. Oh, God, it's driving me nuts. My God, I'm not going nuts and hearing things.
It doesn't mean you're not going nuts.
Oh, it's true, it's true. It's definitely true. Alright. Hear me out. Alright. Okay, so we're gonna do a triangle again. So on your paper, draw a triangle, random triangle. Okay, right, has to be right though, not a random triangle, has to be a right triangle. Okay, now on your triangle, I want you to pick two of the walls, any two walls. It could be the hypotenuse, it could be the legs, it could be anything you want. Two walls. You need to make up your own numbers now. Try to keep them below 3 digits, so 2 digits or below, so single digits or double digits. Put the numbers anywhere you want, okay? And what we're going to try to do is do the Pythagorean Theorem on your particular triangle to find the third wall that you didn't label, that you didn't put a number. Now when you're labeling your triangle, make sure you have a label, like feet, meters, centimeters, inches, I don't care what you have, it could be yards for all I care, but label your answers. And what we're going to try to do is find one of the walls. Okay? We're going to find one of the walls. Now, I'm going to make up my own just so you can see mine. I'm going to say, maybe, I'm going to try to find the height of a building here. So this is my building. Here it is. There's my building. These are terrible windows. Oh my goodness. All right, there's my building. And let's say the ladder here is a 50-foot ladder. And I'm standing, I don't know, 20 feet from the building. I'm standing here. Here's me. I'm going to find that ladder. All right. How tall is the building? Now, just think about it for a few seconds. If that was my problem, common sense, is the building really tall? No? Okay. Well, what should the height of the building be less than?
The ladder.
Yeah, exactly. It has to be less than the ladder. Because the ladder is literally leaning up against the building. It's leaning against the building. So the ladder is bigger than the building. Because if you were to like take the ladder and put it up against it, the ladder is like way tall, right? It's a huge ladder. So the ladder is bigger. So the building has to be less than 50 feet. So, maybe if a story is 10 feet roughly, it's less than a 5-story building. No? But I want to find that. So if I do the Pythagorean Theorem on this particular example, which wall is the hypotenuse? The 50-foot ladder. Because again, I don't care which number you're missing. So in my case, it's x squared plus, 20 squared? These are my legs. And the 50-foot ladder is the hypotenuse. Again, only one of the walls can be missing. Now I'm going to walk around, I'm going to check your problem out, see what numbers you have. But again, you want to solve. So if I square these, 20 squared is 400, and 50 squared is 2,500. I would subtract that over, get 2,100, and then I would take the square root of that. And I have no idea what the square root of 2,100 is. And I know it's 10 over 2, 21. Say it again, please. 25 point what?
45.
So,
Square root of 2,100.
yeah. Say it again.
It's 45.8.
8, sorry. I thought you said 25. Can't hear you. All right, so 45. That made sense. We said it was going to be less than 50. And, yeah, okay. So that makes sense to me. It had to be kind of big. I mean, 21's really close to 25, so, close to 50 feet. So maybe a 4-story building, something like that. 45 feet. So, maybe my drawing was actually pretty accurate. 4 stories. So, not bad. Pretty good guess. Pretty good guess on that one. All right, but now, here's what I'd like to do. I'd like you, on your problems, to try it out by yourself. So, try to set up your Pythagorean Theorem, try to see if you can solve it. I want to see the decimal. So if yours is a decimal, go 1 or 2 decimal places. Like this, I maybe go another decimal place. But pretty accurate, so not bad. All right, I'm going to walk around. I want to see what you have. Now again, if you're missing the hypotenuse, maybe you're missing the ladder, that's fine. Figure out how tall it is. But on mine, I had to subtract this number over. That's how I got the 21, right? But I want to double check what your numbers are. So if you have it, let me see it. I should see, the picture on your paper, some of the work and what your answer was. And I'm going to just see, does your answer make sense? Okay. 6, 16, 20.
Oh.
That's okay. All right. Draw a random triangle. Throw some numbers on. Try the Pythagorean. Yeah. Yeah. Okay. Keep going. Double check. Not bad. And you can always definitely calculate it if you want. Okay, that works. Good.
Yeah.
All right, good. You want the exact, you just calculate the exact. Oh, that's nice. That's really cool. All right, see this one. Zoom in on this one. Yeah. Nice. Yeah. That's good. Those are decimal. What do we get for the roughly the decimal? Okay, 1,500, that's 1,000. And then hit the square root button, which is that button. That's 30. Yeah, makes sense. And I mean, that fit kind of with what your numbers had there. Good. Yeah, again, great questions. Like if you want to know how to type in your calculator, you're not quite sure, this is a great time to ask. Those are good questions to actually go over. Okay. Squared, which is 121. And then you 25. Yeah, 70. 128, right? So double check that over. Have these numbers and see what you think. Okay. The numbers make sense. I mean, these were kind of smaller numbers, so it makes sense. Very good.
So this is like 5, this is 13, what number is that?
Yeah, 26 times makes sense, because that was kind of a bigger number, so having those times.
What is the square, so what is the square root?
Actually, here's what it is. Really nice. All right, I might actually ask you. That was actually nice. That's the only one I've seen that actually has a nice number on it. Nice. And yeah, the number makes sense because what you have right now. Okay. Did I not check anyone else's? Sorry. Check your chat. Come on, Dad. So I'll see you. All right, so you did 4 and 6. 6. Say there we go. That number makes more sense. Okay, okay. 10 and 7. And 12 and 2. All right, that makes sense because the numbers were 10 and 7. So yeah, they're kind of smaller numbers and you're in square root of 4. Yeah, that's good. Okay. So you did 12 and 144 and you had 4. You subtract that over, got 140. Take the square. Yeah, that made sense because the number was 12. That was probably the biggest wall. So numbers make sense. Good. Okay. Anyone else want help like typing it in at all? Okay. I want your numbers, Adam. Yours actually worked out to be like perfect numbers. I actually want that. All right. So let me get rid of my drawing here. In fact, I'm just going to get rid of the whole PowerPoint thing here. Let's get rid of this. Right. Let's get rid of that. Okay. So, Adam, fire away. What were your numbers in your right triangle?
My hypotenuse is 10, and one of the legs is 8.
8. Okay. So, now, all the numbers you guys are creating, perfect, nice. The thing that threw me off was that Adam, the numbers he picked actually works out to be like a perfect square number. And I want to explain this. This is just one of the things. So on his, he set it up where, these are the legs, and he talked about his 10 was the hypotenuse, so x squared plus 8 squared equals 10 squared. So his numbers were 64 and 100, and he subtract that over, and he got 36, which is a nice perfect square. So when he took the square root of it, he got actually 6, which made sense for his, his triangle, that these walls were going to be small, that was going to be the big wall, but it worked out to be a perfect number. The reason why I liked his example was because it just so happened the 3 numbers he chose are what they call a Pythagorean triple. It's 3 numbers, like what you guys are creating on these types of problems, but they worked out to be a perfect square for every single one of them. There is select perfect Pythagorean triples in mathematics. There's only a select few of them that we have in math. You just happen to stumble on one of them, which is actually really impressive. Because usually, like most people in here, you had decimals and you had square roots and stuff, which is good. I mean, that's more practical uses, everyday stuff. Will be not perfect numbers, but you just happen to stumble on one, which I was actually really impressed by, because usually people don't find those types of numbers. But there's select few. 6, 8, 10 is kind of one of them. It's actually a multiple of the original. But it just kind of, it's kind of cool that you can see that. Okay. Now, square roots on your calculator. If you don't know how to get to the square root button today, those are great types of questions that I want to go over. Now, here's kind of the cool part that I haven't discussed yet with this stuff. I've hinted at it. That the Pythagorean theorem, right, the theorem that we're doing right now, it's based on the homework you guys just did, right? The page 541 stuff. What you guys were doing in that homework, for the most part, we were doing triangles like this. And you guys were doing triangles where they had the right angle floating up in the middle of nowhere. They had the altitude coming straight down, and then you were finding all the weird pieces of it. The cool part was that if you got used to the homework, it was pretty straightforward, pretty easy. They gave you a couple things. Maybe they wanted you to find x here, and they gave you the part closest to it, and this whole bottom, which was, let's say it's 10. We could find x because you could use the leg theorem. Right, that was one of the previous theorems that we did. You put the x here and here, put the part closest to it, and the whole bottom, and we did the math, and we talked about how to find square roots. But the one thing I didn't tell you was that once you found x, so the x on this case, you took you multiply the x's together, that's x squared. You multiply 7 and 10 together, you get 70. You took the square root of it, which is the square root of 70, right? And you could type the number in. It would be a weird decimal, somewhere around 8 point something, right? Now, the thing I didn't tell you is that if we actually have had this Pythagorean theorem, like before we did this previous homework, we could have actually, now that we know that this x is a 70, right, the square root of 70, you could have actually used this formula to find this guy, the y. You wouldn't have to use the leg formula again. Now I know you could do the leg formula where you could put the 3 here because the bottom has to add up to be 10. So this has to be 3, and you could do the leg formula like this, where you put the y here and here, and you put the 3 and the 10, and you do the whole leg formula again. But you could have done the Pythagorean theorem, I didn't discuss it, because it is a right triangle. You can see the big right angle at the top, where the number I'm missing is the y. I have one of the walls, one of the legs is root 70, and then the whole bottom, the hypotenuse, is 10. And we could have done this formula. I just didn't discuss it with you because we didn't get there yet. But now you can start to see all the formulas we're learning all kind of tie together. They can actually help you out now. That you can actually find certain walls of these triangles using other formulas as well. Not just always doing the leg formula or doing the altitude formula that we did, but you can actually find other ones. But I thought it was just kind of a cool tie-in that you could have done those problems differently. And to prove the point, just because I have that math that I just showed you here, you could have done this way of doing it, the leg formula, or you could have done the Pythagorean theorem where you take y squared plus the root 70 squared and set that equal to 10 squared. Now when you square the square root, these cancel each other out. They're actually opposites of each other, square and a square root. So you'd be left with 70 there. And this is 100. You could subtract that over, which is 30. And then you take the square root of it. But again, you'd have to know that when you take a square of the square root, it cancels out the radical, or opposites. And if I did the math over here, it's the same math. 3 times 10 equals y times y. And you can see that's the same math I was just doing there. So some people like the leg formulas, they're easier, but some people like the Pythagorean theorem. Maybe that makes more sense to you. Okay, questions, comments about the Pythagorean theorem as of this moment? Alright, here's the thing. I'm going to show you kind of a video here that kind of shows you the reaches of this theorem, right? I talked about yesterday that it's one of the most famous theorems in mathematics. We've been using it a long time, and it's one of those things that kind of everybody knows. They learn it in junior high. But I want to show you kind of the reach of how far this thing goes. So, this is a short little clip. I think it's really funny, but I want to discuss it after we're all done today. Okay? Alright. So, if you just want to watch, it's about a 2-minute clip. Alright, Miss Edwards, you want to hit the lights for me, please? Thank you. Alright. what you're going to watch is a clip from The Wizard of Oz. It's the 1930s version of Wizard of Oz with Judy Garland. I think everyone's probably seen this movie before. It was one of the first films in color, Technicolor. So that's why it's pretty famous. And Judy Garland herself was extremely famous for her singing ability. But this is near the end of the film when all of our main characters from The Wizard of Oz, you know, Cowardly Lion and the Scarecrow and Tin Man, they all met with the wizard, and they're trying to get their heart, their brain. They're on a quest to get these items. And this is a scene where they're talking to Scarecrow about he wants a brain, right? So this is where the wizard is talking to him. And I want you just to catch something, because no one else would probably catch this other than math students.
Why, anybody can have a brain. That's a very mediocre commodity. Every pusillanimous creature that crawls on the earth or slinks through slimy seas has a brain. Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Comitiatum e Pluribus Unum, I hereby confer upon you the honorary degree of PhD. PhD? Doctor of Theology. Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, John!
Okay. There's just one of those scenes that a lot of people wouldn't catch that. I'll play it one more time. I won't play the whole thing. I'll just play that one part where he gets his degree. But I want you to catch what Scarecrow says. Okay? If I need to turn it up, I will. But I think it's fairly loud.
Doctor of Theology. Sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, John!
Okay, so did you catch what he said?
It's isosceles, but it's right.
Okay, so if you didn't catch that, it talks about isosceles. He talks about square roots. Okay, it's one of those inside jokes for Hollywood. You know, did the Scarecrow actually receive a brain or not? But it was one of those things I wanted you to catch that quote. Okay, so here's what I need you to do. I'd like you to take out your Chromebook, please. Take out your Chromebook. See how well you're kind of paying attention today. Okay, I'm going to send you an email here in a second, and I want your honest feedback on things you caught today in today's lesson and yesterday's lesson. Okay, you'll receive an email from me here in a second. Miss Edwards, if you'd like, I can send one to you too if you want.
Oh, sure.
Okay. All right.
Mine's in my phone. Oh, it's just.
There you go. Ooh. Yeah, that's my bad. Yeah, I forgot. I have Go Guardian turned on, don't I? Oops. My bad. Apologies.